A big hello to everyone in honors pre-calculus. Mr. Bigelow here. This is our first official lesson of the school year, lesson 1.1, 2D coordinates and lines. Just a reminder, while you're watching this, remember to take notes. And you can do that by either printing out the blank notes that are provided on Schoology and writing right on the paper, or you can use your own lined paper. Just remember that the notes will be checked. You're going to have to submit photos of your own handwritten notes. So it's very important that you take the notes while you watch this video, and that will be worth a grade. And then also, once you finish watching this video, you also need to complete all assignments related to this lesson as described on Schoology. All right, so take a look at this lesson overview here. Here's what we're going to do in this lesson. In the top left box, we're going to review important algebra concepts. Nothing in today's lesson should be brand new to you. We are going to review the distance formula, the midpoint formula, the Pythagorean theorem, how to write the equations for lines, and what can we do easily with parallel and perpendicular lines. The essential question for today in the bottom left is, how do you write equations for lines given coordinates and other useful information? You should be able to answer that question in full after watching this lesson. In the top right, what you should already know, how to simplify square roots without giving a rounded decimal. You might be a little bit rusty on this, so we'll have some practice built in with the first couple of examples in the notes in just a second. And in the bottom right, what will you be able to do after this lesson? This is an example of a question that you'll be able to answer. You'll be able to find an equation of the line that passes through the point 2, -1, and is perpendicular to the line 2x minus 3y equals 5. Maybe you look at that and you're a little rusty, might not be easy to remember how to do that. Maybe you look at that and you already know. Either way, this lesson is going to be a good review, and it's going to get us set up for the procedures for all of our lessons from here on out. All right, so I'm going to pause recording while I switch to the notes. Give me 1 second. So here we have our official notes for lesson 1.1. And again, this is available on Schoology if you have a printer and you want to print it out. Otherwise, you can just write this on your own paper. And feel free to pause and write things down as you need to. I'm going to be going fairly quickly through this since it's a lot of review. But again, slow down if you need to. So to start off my notes, I usually always have all of the formulas or definitions that you'll need at the top before we get to any examples. So we're going to fly through some of these definitions, then move on to some examples of how we use all this stuff. So first thing we have here is the Pythagorean theorem. Hopefully this looks familiar. A squared plus b squared equals c squared. For any right triangle, there are two legs and a hypotenuse. The hypotenuse is always c. And if you take a, the length of a, squared plus the length of leg B squared, you always get the length of the hypotenuse C squared. That'll come in handy with some of these questions. We also have the distance formula here. If you have 2 points and you call them x1, y1 and x2, y2, you can plug them into this formula. We have the midpoint formula. Midpoint formula is just a fancy way of doing the average of two numbers, right? You add two numbers and you divide by 2. That's finding the average. So to find the midpoint between 2 points, you find the average of the x values and the average of the y values. It just looks a little fancy. Next up, we have slope, intercept, form. And M stands for the slope, and B stands for the y-intercept. There's a reason why it's called the slope-intercept form, because it has the slope and the y-intercept built right in. We also have point-slope form, which, as you may guess, gives you the slope and a point on the line. And it can be any point on the line that you can plug in as x1 and y1. In both of these equations, the x and the y don't get plugged in for your initial form of the line. Next up, we have the slope formula, which is commonly called or referred to as rise over run. It's the change in y's over the change in x's. And if you have two parallel lines, they have the same slope. And perpendicular lines have opposite reciprocal slopes. And opposite reciprocal sometimes throws people for a loop. Opposite means that we switch the sign from positive to negative or negative to positive, and reciprocal means that we flip the fraction. So if it was 1/2, now it's 2/1. If it was 4, think of that as 4/1, and we flip it to 1/4. And again, we would also switch the sign. All right, so that's the basic definitions that we need. Hopefully, that was pretty simple. Hopefully, a lot of that was review. But again, we're doing this for a reason. So if it is something that you haven't seen for a while, hey, that's why we're looking at it. Okay, example 1, distance formula. The distance formula is derived from the Pythagorean theorem. There is a relationship between this formula and the Pythagorean theorem. If you square both sides here, we would cancel out this square root. We would square the d. The d is kind of like our hypotenuse here. And the x2 minus x1 is like our a. The y2 minus y1 is like our b. You don't necessarily need to write that down, but just it's good to know that the distance formula is really just a fancy way of writing the Pythagorean theorem. But let's try it. Okay, find the distance between -2, 1 and 3, 4. Give your answer as a square root, not a rounded decimal. So that's where that square root comes in that we were talking about with the what you already know before this lesson. We're going to label these points as x1, y1, and x2, y2. And then we're going to plug them in. So real quickly, here's our formula, x2 minus x1 squared plus y2 minus y1 squared. And we're going to plug them in. Shouldn't be too bad. We have x2 minus x1 and y2 minus y1, both sets squared. This is a minus a negative, so it's really a plus. And then we do some of the math. So we have 3 plus 2, so we have 5 squared plus 4 minus 1 is 3 squared. So we're going to have 25 plus 9, right? And that's 34. So we have the square root of 34. And the question said to give our answer as a square root, not a rounded decimal, but we want to simplify this square root. So I'm going to think about, okay, can the square root of 34 be simplified? And the way that I usually do this is to write down the prime factorization with a prime factor tree. So you might have done this before. I think most of you probably have. If we start with the square root of 34, we got to think, okay, what numbers multiply, what's an example of two numbers that multiply to get 34? And the first thing I think of is that it's even, so it can be divided by 2. And it's 2 and 17. And both of those numbers are already prime now. So we can't break down 2 further. We can't break down 17 further. I don't have any pairs of prime factors, so I can't pull anything out of this square root. So that's actually our final answer. And then let's take a look at letter B. So we're going to do the same thing. Find the distance between these 2 points. And plug them in. So we have x2 minus x1, y2 minus y1, 9 plus 5 is going to be 14, 3 plus 3 is going to be 6, and we end up with square root of 196 plus 36, which is 232. All right, so 232, a little bigger than our 34 that we had before. We're going to go through again and try to break this down. So 232 is definitely even, so you can break it down into 2 and 116. 116 can go further to 2 and 58. And 58 can go further to 2 and 29. And then we're stuck. So what I usually do is I go through and circle the ends of all of the branches. So 2 was the end here, 2 was the end here, 2 and 29. Those represent the prime factors that make up 232. So if I do 2 times 2 times 2 times 29, I get 232. And I'm looking for pairs, because if there's a pair of prime factors, it means that there's a square we can pull out of the root. So what we do here is we write in our root. So for 232, for any pair of numbers, there's a pair of 2's. I can cross off both 2's and write a 1, 2 outside. There's another 2, but it doesn't have a partner, so I can't cross that one off. So anything that's left over that doesn't have a pair gets multiplied inside the root like this. So our final answer is 2 root 2 times 29, which is 58. And that's our simplified version of the square root. Okay, so that's example 1. That's how we use the distance formula. Let's take a look at example 2, the midpoint formula. Again, the midpoint formula is just finding the average of the x values and the average of the y values. All right, so let's take a look. Letter A, find the midpoint of the line segment joining points -5, -3, and 9, 3. So we take that formula, which was x1 plus y1 over 2, whoops, I messed that up. It's x1 plus x2 over 2, y1 plus y2 over 2. That's an x. Okay, and so we're going to plug in our points. So we plug in the x values to the first fraction, so it's -5 plus 9 over 2, and the y ones are -3 plus 3 over 2, and that's going to leave us with -5 plus 9 is 4, so 4 over 2 is 2. -3 plus 3 is 0, 0 over 2 is 0. Basically, if we plotted these points, this isn't the actual points, but here's an example. If that's the 2 points, the midpoint is going to be directly between them, like this, given a with the same distance between this point and this point, and the same distance between this point and this point, right? That's what a midpoint is. Letter B, same idea. We have -2 plus 3 over 2, and 1 plus 4 over 2. -2 plus 3 is going to be 1. 1 plus 4 is going to be 5. This one left us with fractions. We can't reduce that. So you could write it as 1/2, 5/2, or if you wanted, you could write 0.5, 2.5. Same thing, right? So that's how we use midpoints. So let's look at example 3, verifying a right triangle. So we're going to bring the distance formula and the Pythagorean theorem together into one. So here we go. Letter A, show that these 3 points are vertices of a right triangle. So step 1, we're going to find the distance between each pair of points. And then we're going to see if the Pythagorean theorem holds true, right? Because if you think about a right triangle, we have 3 sides. Right now, we're just given 3 points. So what we're going to do is figure out the distance between this point and this point, this point and this point, and this point and this point. So we'll then have the 3 lengths of the sides of the triangle. And then we're going to see, does it make a right triangle? Because if it does, a squared plus b squared equals c squared should hold true. All right, so that's what we're going to track. So here's what I like to do. I like to label these points as point A, point B, and point C. And then we are going to actually write the distance formula 3 times. So I'm going to do the distance between A and B, the distance from B to C, and the distance from A to C. That's how I write it so that I can keep it clear. And okay, so we got the distance formula 3 times. Just in case you didn't have enough practice with distance formula, here it comes again. So remember, it's x2 minus x1 squared plus y2 minus y1 squared. So we have 4 minus 2 squared plus 0 minus 1 squared. So it's going to be 2 squared plus -1 squared, which is going to be 4 plus 1. Remember, a negative times a negative is positive. So that's 4 plus 1, so we get root 5. All right, for the rest of these, I'm not going to write out every single step like this. I'm just going to already do the subtraction before I write it to make it a little shorter. So for B and C, we have 5 minus 4, 7 minus 0. And for A to C, we have 5 minus 2 and 7 minus 1. It's going to be 9 plus 36, which is 45. Yes, okay, so some of these radicals can be simplified. Remember, a radical is another name for a square root. So some of these square roots can be simplified, but when you're verifying a right triangle, I actually recommend you don't simplify it because it's gonna make it easier later. So now we have to see, does it hold true for the Pythagorean theorem, a squared plus b squared equals c squared? And we need to know which side is c. So a little trick here is that the hypotenuse is always the longest side. So since this is the longest side, this is gonna be our c. And so I'm gonna plug in here, and so I'll just, a and b don't matter, so I'm just gonna make this one a, this one b, equals this one. And notice the reason I didn't simplify my square roots is because now the square roots and the squares cancel out. So we get 5 plus 45 equals 50, which is definitely true, right? 50 equals 50. Check. Awesome, perfect. Okay, so let's keep going. Letter B. I'm just gonna kind of write this one down without speaking through it, and you can follow along. All right, so there you have it. This one actually worked out. The square roots became normal numbers. They were all perfect squares. So we had a 3, 4, 5, which you might already recognize as a Pythagorean triple. It makes a right triangle, and it worked. All right, so let's take a look at example 4, an application question. Football quarterback throws a pass from the 28-yard line, 40 yards from the sideline. Pass is caught by a wide receiver on the 5-yard line, 20 yards from the same sideline. How long is the pass? Round your answer to one decimal place. So we're going to draw a sketch here first. So what I would do is kind of draw the sideline. I'm going to make this over here 0. This will be the end. And we need a 28-yard line and a 5-yard line. And even if you don't understand football, you should be able to figure this part out. Kind of draw it like a number line. I drew mine backwards. It doesn't really matter. And then we are 40 yards from the yard line, from the sideline over here. So we're going to say that that's 40. And then we are 20 yards from the sideline over here. So there, that's going to be 20. And this is the length that we're looking for. Okay, obviously this is not to scale, but that is fine, doesn't matter. This is where the pass is thrown from. This is where it's received. And now we need to know, how long is the pass? Well, this looks like a perfect scenario for the distance formula. We can kind of make these into ordered pairs. This could be 28, 40, and this could be 5, 20. You know, it's a little backwards for our ordered pairs, how they usually are, because we're going to the left of the 0 in my drawing, but it doesn't matter. We have consistent ordered pairs, and we can use the distance formula. What the distance formula is going to do is figure out this length and this length to make a right triangle. And then the answer is going to be the hypotenuse, which will be how long the pass is. So let's try it. So we have distance equals square root of, it's going to be 28 minus 5 squared plus 40 minus 20 squared. And that'll be 23 squared plus 20 squared, which is 529 plus 400, which is the square root of 929. Now we could simplify that radical, but the question says round your answer to one decimal place. So in this case, we can type that into our calculator. You're going to be able to round that to 30.5 yards. There we go. Very nice, very nice. All right, let's keep going. Letter B, Barnes & Noble had an annual sales of approximately $5.1 billion in 2005 and $5.4 billion in 2007. Assuming the sales follow a linear pattern, use the midpoint formula to estimate the 2006 sales. So what we can do here is kind of write this as two different ordered pairs. I'm going to put the year first, so it could be 2005, comma, 5.1. We're just going to assume that that's in billions. And then 2007, we have 5.4. So if the sales follow a linear pattern in 2006, you should be able to tell that we're just looking for the average of these two numbers to find what's directly between them. But we're going to use the midpoint formula. So for the x, we would do 2005 plus 2007 divided by 2. For the y, we would do 5.1 plus 5.4 divided by 2. And this is going to reduce to 2006, 5.25. And that gives us an answer of $5.25 billion in sales. And thinking about this, so this was all the way back in 2006. Unfortunately, I bet you that the sales are probably going down for, in-person bookstores, just because of everything online. So I don't know. I haven't looked that up, but I bet this is gone down since then. Let's keep going. Example 5, graphs of linear equations. So here we're switching gears a little bit. We're moving into lines and how to graph them. So this first one's already in slope-intercept form. Think about the form y equals mx plus b. The 2 is obviously the m, and the 1 is the b. And then the question is, how do we graph this? Hopefully you remember this, but that's why we're reviewing, because I'm sure some of you need this. The b is where we start, right? The b is the y-intercept. So on the y-axis, we go to the 1 and we make a point. And then our slope is 2. So we're going to go up 2 over 1. We always think of it kind of as a fraction, as our rise over run. Up 2 over 1, up 2 over 1. And if you didn't print the notes out, if you just make a rough sketch of this, that's totally fine. It doesn't have to be perfect. Then I'm going to connect the dots. There we go. There's our line. Let's take a look at the second one. Y equals 2. So if we think about kind of making that into mx plus b form, it would be like 0x plus 2. Because the x doesn't even show up. So it's like the coefficient is a 0. It's like the number in front of the x is a 0. So in this case, our slope is 0, and our y-intercept is 2. So we still make a point at 2 on the y-axis. And with a 0 slope, that makes a horizontal line. So it's going to go straight across in both directions. And for the third one, now we're not actually in slope-intercept form yet, so we're going to subtract the x from both sides so that we can make this into the right form. And we get y equals negative x plus 2. I like to write the negative x first because that's the same form then as mx plus b. So our slope is negative 1 and our b is 2. We're going to start at the 2. We have a slope of negative 1 over 1. So we go down 1 over 1, down 1 over 1. Make sure from left to right, if your slope is negative, that your points should be going down, like a negative sloped line. Okay, and then we connect all the dots, and there's our line. Very nice, very nice. I guess I said that to myself, but hopefully yours looks very nice too. Okay, example 6, slope as a ratio. The maximum recommended slope of a wheelchair ramp is 1 to 12. So a rise of 1, a run of 12. A business is installing a wheelchair ramp that rise is 22 inches over a horizontal length of 24 feet. Does the ramp meet the recommended guidelines? So first of all, the guidelines are saying that we could go up 1 over 12. So something like that, this dotted line would represent the ramp. I'm assuming this is because if a ramp was steeper, the wheelchair would have a harder time going up it or down it while staying in control. And so the situation we have here is going up 22 inches and over 24 feet. So something like this. We want to know if the ramp meets the guidelines. So the first thing I noticed, hopefully you noticed this too, is that the scenario we're given is using 2 different units, inches and feet. So we got to figure out how many inches is 24 feet. And if you multiply that by 12, you get 288 inches. And then we're going to compare the steepness of the slopes. So the first one is 1 over 12. The second one is 288. No, sorry, it's 22 over 288. And I can't tell by looking at those fractions which one's bigger. So I'm actually going to use my calculator and divide these to get the decimals. 1 over 12 is 0.083, and 22 over 288 is 0.076. Whichever number is larger has a steeper slope. So since the given maximum steepness is larger than our ramp, that means that the ramp meets the guidelines. There you go. All right. Awesome. Example 7, the slope formula. Determine the slope of each set of points. We'll start off with letter A here. -2,5 and -2,7. This takes us to our slope formula. This shouldn't be too bad. We have y2 minus y1 over x2 minus x1. So our y2 is 7 and our y1 is 5. x2 is -2 minus -2. So we end up with 2 over 0. And yikes, we're dividing by 0. I have a poster in my classroom that says, it's all fun and games until you try to divide by 0. We cannot divide by 0 here. That gives us an undefined slope. And that creates a vertical line. So it's just going to be straight up and down. There's no slope of a straight up and down line, and you can tell that just by looking at the points. They both have the same x value, so it's going to be -2, 5 and -2, 7. That's 2 points on a straight up and down line. They both have the same x value, so that slope's undefined. Let's take a look at letter B. It's going to be -7 minus 4 over 5 minus 3. So we get -11 over 2. That one worked out. The negative slope, so it's going to be decreasing or going down from left to right. And for the last one, we have -3 minus -3 over 5 minus 4. So that gives us 0 over 1, which is a slope of 0. And a slope of 0, as we already saw right here, gives us a horizontal line. So there you go. That is how you use the slope formula. Hopefully that was a nice review for you. Now that we know that, I really like this chart of writing linear equations. So there's 3 different things you might be given. In fact, there's 4 because there's 2 in this box. If you're given a slope and a y-intercept, or you're given the graph of a line, you can use y equals mx plus b right away to write the equation of the line. If you're given a slope and a point, you have a choice. You can use y equals mx plus b, or you can use point slope form. We'll look at both. And if you're given 2 points, first you have to find the slope, and then you use the slope and pick a point, and you're basically back in column 2 here. So you can use slope intercept or point slope forms. So let's take a look at letter A here. We're going to find the equation of the line that has a slope of 3 and passes through the point 1, -2. Give the equation slope intercept and point slope forms. So in this one question, we're going to find the equation 2 different ways. And then after this, you can choose which one you like better. So let's start with with the slope-intercept form. We have that the slope is 3. That's given to us in the question. And we pass through the point 1 comma negative 2. So if we use slope-intercept form from the start, we're going to start with y equals mx plus b. And the process is that you plug the 3 in for m, you plug the 1, negative 2 in for x and y temporarily, so that you can find the b. So we have negative 2 equals 3 times 1, which is 3, plus b. You subtract the 3, and you get negative 5 equals b. So our final answer, we remove the x and the y again. So we have y equals, we plug in the m, which was 3. We leave the x as x, and then we now have our b. So we plug in minus 5, and that's the equation of the line. The other option would be to start with the point slope form. So remember, that is y minus y1 equals m times x minus x1. And we're going to plug in the slope and the x1 and the y1. So we have y plus 2, because it's minus and negative, equals the slope, which is 3 times x minus 1. All right, so that actually answers a question given in the prompt, right? We wanted the equation in point slope form, so we already got it. But I wanted to show you that you can use this to get to the answer in slope-intercept form instead of doing it this way. So this was, remember, this was the first version of how to get to the answer. If we simplify this and solve for y, this is the second way to get to the same answer. So we can distribute the 3, and then subtract the 2 to the other side. And that's the second way to get the slope-intercept form of the answer. So it's up to you. I think over the years, I've learned that students typically prefer the slope-intercept method from start to finish instead of kind of working with the point slope form, but it's your call. Okay, and that brings us to the last set of examples in the notes. Parallel and perpendicular lines. Remember, parallel lines have the same slope, and perpendicular lines are at a right angle to each other. They have opposite reciprocal slopes. So if we wanted to find an equation of the line that passes through the point 2 comma negative 1 and is parallel to 2x minus 3y equals 5, the first thing we need to do is find the slope of this line. So I'm going to have to solve this for y equals so that I can see the slope. So I'm going to subtract 2x. And then divide by negative 3, and I have to divide every single term by negative 3. So we get y equals 2/3 x minus 5/3. All right, and right here, this is our slope. So remember, this line that we're solving right here, this is some other line. And all we care about is being parallel to this line. So we're not going to use this y-intercept. This is not our line. This is some other line that we're parallel to. So we're going to use this slope of 2/3. And we know that our line passes through the point 2 comma negative 1. So now that we have that, we know our slope is 2/3, because we have the same slope because we're parallel. And it passes through the point 2, negative 1. So now we have to pick one of the two methods to solve for the equation of the line. So I'm going to start with y equals mx plus b, because that's usually the most popular. We're going to plug in the y, plug in the m, and plug in the b. No, we don't have the b. I'm going to plug in the x of 2 plus b. So we have negative 1 equals 4/3 plus b. And I'm going to subtract 4/3 to the other side. We have negative 1 minus 4/3, which is negative 7/3 equals b. Maybe you are a little bit rusty on subtracting fractions. I would think of the negative 1 as negative 4/4. Just kidding, negative 3/3 minus 4/3 would give us a negative 7/3. Alternatively, your calculator can do this for you if you have your graphing calculator. You can type in negative 1 minus 4/3, and gives it to you as a decimal. But if you click math 1, enter, then it changes it to a fraction for you, -7/3. I really like -7/3 more than if you gave this to me as a mixed number. What would it be? -2 1/3. In pre-calc, it's accurate. You can write it, but -7/3 is just going to be more helpful. If you write -2 1/3, when we get into more complicated math, it's going to be confusing whether you mean 2 1/3 or if you mean 2 times 1/3, which is totally different. So I prefer you just don't write that. Let's just leave it as -7/3. So our final answer is y equals, we got to recall that slope, and now we have the y-intercept. So there we go. That's our line that's parallel to this line, and it goes through this point. So now we are going to find an equation on the line that passes through that same point and is perpendicular to the line. This is actually the same line, remember? It's literally just copied from right there. So we already found the slope. So this changes into y equals 2/3 x minus 5/3. We already know that. We are now wanting to be perpendicular to this. So we're going to take this slope and find the opposite reciprocal. So Rm is going to be flipped. So instead of 2/3, it's 3/2. And we change the sign. So now it's negative. And if you graph that, you'll see that it has a right angle to this slope, right? That's a fact. You probably saw that in algebra 1. So we have -3/2 as our slope. And again, we go through the point 2, -1. So we're going to use y equals mx plus b and start to plug this in. The y is -1. The m is -3/2. The x is 2. So now we have -1 equals -3 plus b. We add the 3 to the other side. We have 2 equals b. And then we can write the equation. So we have y equals -3/2 x plus 2. There we go. So this line is perpendicular to the given line, but it also goes through the point 2, -1. So at some point, this line and this line intersect at a right angle. And that's the end. Thank you very much for watching.